My name is Daniel White, Managing Director of Operations for CTI Connect, and I'm really excited to see everybody in the room this morning. The panel today is on disruptive technologies. So the concept behind the panel is to discuss the technologies you may not be deploying in your WISP today and how they can disrupt basically your plan moving forward. So what do you need to be looking at to take the next big step in your ISP? So we got a great panel today. We're going to focus really on three topics, and that's millimeter wave technology, specifically the latest trends in, say, 60 gigahertz multipoint and very high capacity point-to-point. Then we'll have a little part about Gfast, and then last about SDWAN technology. The way I like to run panels, just so everybody's kind of aware, is that typically we spend about 30 minutes on the slides. I like to try to keep it to 30 minutes max, about 10 minutes per topic. And then I really encourage question and answers. So as you listen to the speakers speak, please write down questions. And then we should have about 20 to 30 minutes for questions, because I do not want to bore you with death by PowerPoint. It's one of the worst things for me when I'm in the audience to see is thousands of PowerPoint slides with no opportunity to ask questions. So I really encourage you, the best way that everybody gets the most out of the session is if you write down questions and you come up and ask them once we get to the Q&A. So with that said, I'd like to introduce up David from Siklu to speak about millimeter wave technology.
All right, thank you. Good morning, everybody. So as Daniel mentioned, my name's David Sumi. I'm responsible for marketing at Siklu, and I'm going to take just a few slides to give you some highlights about what we do and some of the key products. The topic here is disruptive technology. I think there's a lot of disruptive technology coming out in millimeter wave currently. You see it a lot on the show floor, and it has a lot of promise. And I think we'll try and explain and answer your questions today is how is millimeter wave really going to revolutionize what you're doing with your customers. Brief company snapshot. The company is actually 10 years old this month. So why is that important? Because 10 years ago, Siklu looked at the millimeter wave, the 60, 70, 80 gigahertz frequencies, and said, there's some really good benefits to that band, but it's way too expensive today. So 10 years ago, the team got together and started working on silicon germanium chips. How can we improve performance, and how can we really reduce the cost? Because the market was never going to be successful if the cost didn't come down from where it was 10 years ago. Today we have over 60,000 links deployed worldwide. That 86% number you see is the US 2017 E-band market share for Siklu. Looking at the FCC lightly licensed database for 70, 80 gigahertz, you'll find that 86% of the links registered in 2017 are using Siklu equipment. So we feel with our 10-year pedigree, these types of numbers, clearly if we are not the leader in the millimeter wave in the globe, then we are certainly one of. The portfolio that we offer, and this is, in the disruptive technologies, there's both point-to-point and point-to-multipoint technologies that are coming to fore. The point-to-point is really where Siklu has done most of its historical investment. So we have two product lines. One is really kind of the classic microwave dish on a building or on a rooftop or on a tower. The other is what we call our street-level products, which are much, much smaller. They're designed to go on a light post or a traffic signal arm, things like this, down at the lower, and it needs to be smaller elevations. And then we have our point-to-multipoint product, and this is probably, I think, most of the buzz you're seeing in millimeter wave, especially at this show, is a number of companies talking to you about point-to-multipoint in the 60 gigahertz band. This is very exciting. This technology is going to give you the opportunity to deliver gigabits to your customers. What are they going to do with the gigabit? I'm not quite sure, but I do know that the market wants gigabits. Verizon's pushing this, and when Verizon pushes it, the cable companies follow. With all of that, you as WISPs and wireless ISPs, you need to have solutions that can get you a gigabit to your customers at a cost point that makes business sense for you. Our point-to-multipoint product, we call it the MultiHaul. It's in the V-band, so for those of you who aren't familiar, you'll hear E-band, V-band. Interestingly enough, V-band is the 60 gigahertz, or the lower frequency. E-band, when people are talking about that, they're talking about the 70 and 80 gigahertz. All of the point-to-multipoint products that you're hearing about in millimeter wave are in the 60 gigahertz band, and there's a really good reason for that. There are now there are now chips out there that support 60 gigahertz, the modem, the RF, and this is where you're starting to see these very cost-effective products hit the market. That said, we're all kind of tied to the same silicon, so where you innovate in products such as this is in your RF front end, your antenna design. You really want to try and push these links as far as possible with as high a capacity as possible. Again, our goal is 1 gigabit per customer, and if we want to be able to do that, we want to do it as long a distance as possible. So with our MultiHaul, our base station has a 1.8 gigabit per second capacity. That's actual, what I call Ethernet throughput. And that is shared amongst 8 terminal units that can be arrayed maybe 350 meters, about 1,000 feet away. It is line of sight, which is important. Maybe you get lucky here and there with a 60 gigahertz non-line of sight deployment, but for your purposes, you should not count on that. These products and these technologies, you really need to plan on line of sight connectivity. With each base station unit covering a 90-degree sector, one of the things that makes our product different, if you will, from our competitors is we've implemented beam steering in this product. So there's no alignment with the terminal unit. The base station is constantly steering the beam towards the right area, and this gives us, a little bit further distance and a little bit more functionality in terms of talking to the terminal units. Just a couple additional things about the product. These are more detailed. I think some people are interested. Very, very robust. So we go for what we call a carrier quality product. These things are IP67. What IP67 means practically is I can take this, dip it under a meter of water for 30 minutes, and it does not leak. That's an IP67 rated radio. We've had systems that were in Puerto Rico in the last few hurricanes. They've all survived. They've all come through. So we tend to really focus on the high quality, very, very robust, very rugged, high temperature range product line. That's kind of our DNA. Moving on, we've also announced last week, and we're willing to talk to people in our booth if you want to come by, it's our 10 gigabit per second. I think this product and other products like it are where people are starting to look at millimeter wave and say, holy cow, 10 gigabits per second full duplex. While maybe we're not talking fiber speeds, you're certainly getting up to a capacity where you can start filling fiber pipes. What this lends is a big application that we see is fiber extension. Fiber is great. We all love fiber, but we don't like paying for the cost of extending fiber into an area that might not quite have the business to justify it. This is where wireless, and when you have a 10 gigabit per second link, really comes into play. For us, with our 10 gig product, again, where do we differentiate? The range. The RF front end, the antenna design, all of these things give us a very, very good range in our 10 gigabit full duplex product. And we've just announced this product. It's available, I think, in about a month. You can start ordering it now. Some of the specs are there. Very, very sophisticated, multiple ports. We have a very high performance layer 2 switch built into this product. This really is useful for topologies if you want to do ring topologies. If you want to backhaul 4 of our base stations through one of these links, you can do that. So the 8010, as we call it, full duplex is quite an advancement in giving you capacity and giving it to you distances that can get you 2 miles easily with a high reliability, and the product can go multiple miles beyond that if you're willing to trade availability, looking at your rain fade and things like that. One of the things that we in wireless tend to exaggerate the most is how far our products go. I invite you to go to our website. We have a link budget calculator. It's a very honest calculator because you guys would be complaining if you used our link budget calculator, deployed it, and it didn't work. So when you want to see how far a product can go, what kind of availability your customer is willing to put up with, can they do 2 nines, 3 nines, 4 nines? You can play with all of that in the calculator, and you can see how far this unit's going to go. We do have links with our 5 gigabit product that go as far as 10 miles. But that was in a very low rain region. That was with a customer who was willing to live with a 99% availability. So if those are things that you can do in your business case, then you have that option. Finally, the applications that we're seeing multi-dwelling units. Gigabit to the residential, I think, is really the excitement right now. Businesses and enterprises are the low-hanging fruit. They'll pay more for that gigabit connectivity, but where everybody sees the volume and the mass of the market is dropping a gigabit on a house, dropping a gigabit or 5 gigabits on an apartment building. So this is where, gigabit connectivity, and that's what mmWav is all about, gigabit connectivity, and that's what this product can do. Garden-style campuses, single-family units. Really, for the 8010, this is more of a backhaul for our multi-point products. In the single-family unit, the price points are a little bit high for an individual to have 10 gigabits to their house, or at least for most of us. And that was it. So, I look forward to your questions and comments when we get to that. And for now, I'll turn it over to you, Sean.
Great. Thanks, David. So my name is Sean Holliday, and work with an organization called Scipio Technologies. And just a quick background, Scipio was founded about 5 years ago. We're based in Tel Aviv, Israel, and we're a company that came out of the original DSL. All the engineers that have worked on ADSL, VDSL, even some of the home networking technologies have come together to form Scipio. And we've put all of our efforts now into a technology called Gfast. And we're not actually equipment manufacturers, but we develop the technology that actually goes into the equipment that you'll see available on the market. And before I get started, just by a show of hands, who here is familiar with Gfast technology? Okay, that's good. And of those hands, who here has actually deployed Gfast in their networks? All right, I'm talking to, we got one over there, so I'm talking to the right audience here. So with that said, my plan today is just cover the surface. There's a lot about Gfast technology to go into depth in terms of how the deployment, some BKMs of deploying it. We've spent a lot of time, even in the WISP market as of recently, deploying the technology. So if I can't answer all your questions here, I'm here through tomorrow, always open to sit down, discuss, and go into a bit more technical detail. So with that said, let me talk a little bit about what Gfast is. This is an ITU standard, G.9700 and 701 for the physical layer and the higher layers. The current version of Gfast that you see on the market today is what we call Generation 1 or Amendment 2. It's running at 106 megahertz in terms of total frequency available. That'll get you up to about a gigabit over twisted pair or over coax, depending on your infrastructure. What's going to be coming out later this year is a Generation 2 or Amendment 3 that doubles the frequency band available to us and will get us very close up to 2 gigabits over existing infrastructure. The key thing about Gfast, and what I talk about, is it's a very disruptive technology that minimizes disruption. And what I mean by that is it's going to allow you to take steps well beyond existing technologies like VDSL that you may have used for in-building distribution, and to very easily offer that gigabit or multiple gigabits out to your customers. Over existing infrastructure. So it's the latest and greatest kind of bleeding edge technology in terms of high-speed communications, ultra broadband over existing copper infrastructure. But it's not something you're going to have to do a forklift upgrade. You can actually go out to your buildings, utilize the existing twisted pair or coax infrastructure, and offer gigabit services. Another key thing is, sorry to mention, it works over coax and twisted pair. Coax infrastructure is great because we can actually implement this technology without vectoring. If you're familiar with vectoring or deployed VDSL with vectoring technology, you'll know that it's a bit picky in terms of how you build your groups and how you actually deploy it. Over coax, we can actually utilize G.fast without vectoring. So if you have access to coax, we always recommend that, but it also works quite well over a twisted pair environment, which it's originally intended for. Spectrally compatible with existing DSLs. What we're seeing today with multi-dwelling unit, multi-tenant distributions is multi-service provider environments. When you come into the basement, there may be somebody who has a fiber drop using an existing DSL technology to get out to the apartments. You may see somebody coming in from a street cabinet with a different type. And what that's happening is we're getting a kind of a spectral mess or spectral spaghetti within the building. The great thing about Gfast is that it's easily adaptable to work over those existing technologies. There's profiles, for example, to run over top of VDSL 17A or 35B. Of course, if you don't have those as environments, you can run it over its full profile, but it's very easily spectrally compatible within those environments. Another really cool things about Gfast are dynamic bandwidth allocation. So with existing DSL technologies you may be familiar with, it's frequency-based. So you have to allocate a fixed upstream and a fixed downstream. That may be like in a 90-10 configuration, an 80-20 or 70-30. With Gfast, we use a time domain capability. So that means if you have 500 megabits or even a gigabit available to you, that can be fully allocated to upstream or downstream automatically, and that's called dynamic bandwidth allocation. So it really enables you to offer a symmetric service without having to have symmetric upstream and symmetric downstream available, which is difficult in a lot of situations. Another technology, and this is an innovation directly from Scipio, is cross-DPU vectoring. So as I mentioned earlier, if you're familiar with vectoring technology, it's utilized to minimize crosstalk or self-inflicted crosstalk between the different lines. The reason it's important to have cross-DPU capability is you can actually go into a building and install multiple DPUs and build one vectoring group, meaning that if you start off with a Gfast DPU that only supports 16 lines and you add more customers, you can continually plug in more DPUs to each other to support up to about 96 ports total. So it gives you as a WISP a lot of flexibility to start out small and then build and add more customers as you need to without having to worry about specific grooming for vectoring groups and crosstalk between the units. So it's a really cool feature that's coming out. Another key thing is obviously channel bonding. If you've done anything with DSL, you know you can add multiple channels. Same thing within Gfast. Bonding can be added to either double the speed or double the distance over your infrastructure, depending on what that infrastructure looks like within a building. So let's talk a little bit about the speeds. These are kind of best case scenarios, and of course it really depends on what your in-building environment looks like. Do you have 22, 24, 26 gauge twisted pair in place? Is it Cat 5 or is it Cat 3 or is it just strap wiring or is it coax? The graph on the left is what we're showing for coax, which again is a premium environment for Gfast. You can get well out over 300 meters and over 1.5 to 1.5 to 2 gigabits over that coax that's in place. Now, the one thing to remember with Gfast is that we're point-to-point technologies, not point-to-multi-point. So if you're going to use Gfast in a coax environment, you have to have home runs back to your wiring closet with a coax. It's not going to work over a point-to-point point-to-multi-point implementation. The graph on the right shows the capability over existing twisted pair. And we've kind of boiled this down just into a 24 gauge or a 0.5 millimeter wire or what we just call bad wiring, which is kind of an average of a lot of different environments that we've seen. And so you can easily see that the sweet spot is 150 meters or less, so roughly about 300 feet or so, where you can get up to that gigabit or a little bit more over G.fast. But again, it really depends on the environment. The one thing about G.fast, and a lot of these technologies are using higher frequencies, it takes a little bit of extra time just to understand what's in your building already. As I mentioned earlier, is there existing DSL technologies where you need to make sure you run the appropriate configuration so you're not overlapping each other in the frequency spectrum. And just a few other minor things that allow you to get the best usage of the technology. And those are questions I can answer later. If we've done a lot of installs in different buildings, working with a lot of different WISPs out there and a lot of different fixed wireless equipment providers. So we've learned quite a bit over the last year. I'd love to share that with you guys. So this is probably a picture you're familiar with. As I mentioned earlier, the type of environments you'll run into. Gfast is really positioned to be a technology to help you get your fixed wireless that may be on the rooftop with a gigabit link down to the basement and then out to all the individual customers. And as you guys probably know, when you walk into the basement of an apartment building, whether it be a garden style or a multi-floor style. You may see something that looks like the picture on the left. You may see something that looks like the picture on the right. The great thing is that with the vectoring capability, the algorithms and the technology of Gfast, it really allows you to get through either a lot of the spaghetti mess and get high-speed ultra-broadband communications through that. So we've had a lot of installations that reflect both of these environments, and I can honestly tell you that it works quite well, especially when you're combining it with a fixed wireless coming from the rooftop in order to get those gigabit services out to customers. So last slide I'll talk about here, as already mentioned, we believe Gfast is a great complement to fixed wireless, allows you to easily get out to your customers within a building with minimal impact without having to do a complete rewire of the building, use the existing infrastructure. Just a sample of a few of our equipment partners that are out in the market today, companies like Calix, Adtran, and Fast Networks are building products that are very specific and work quite well in the MDU environment. We're seeing quite a few installations around the U.S. right now. And the really cool thing is, as compared to bringing, say, fiber to the basement, I know there's discussion of fixed wireless versus fiber deployments later today. We're seeing installations from initial building contact to full distribution out to the customers 2 to 4 weeks. That's a radio on the roof, G.Fast installed, customers actually paying for service. So it's a technology that allows you to move very quickly to bring new customers to market. So with that said, I'll hand it off and look forward to your questions as we go through. Thank you.
Hello, my name is John Bachtold. Can you guys hear me? Good. I want a little audience participation, but before I do, I want to give a little bit of introduction of who I am. I started out in internet a while back. I did dial-up. Raise your hand if you've done dial-up here. Okay, good. So you probably remember back in the dial-up days there was analog, and then there came along digital modem sets. And I remember purchasing an $18,000 box that gave me a PRI 24 lines, and I was freaking out whether I would ever recoup my investment on it. And so disruptive technologies like that always made me panic. So my question to you guys are, what did you come to this panel for? Did you come to learn more? Raise your hand if you came to learn more. Okay. What about, did you come to consider these technologies as potentially an investment for you or a capability that you're doing? Raise your hand if you did. Okay. Are you fearful for your current investment? Anybody here just wants to know more to make sure that they invested in the right thing? There's a few, yeah. Okay, good. So you guys probably didn't sleep until you got here, right? You're going to sleep better after this, hopefully. And who just came here because they need a good nap? Anybody? Sometimes that's the case. So are you familiar with SDN? SDN is software-defined networking, right? And SDN really started in the data center. And by the way, I don't sell SDN-WAN. I'm actually currently, I went from a dial-up provider to a fixed wireless provider. I still own a portion of a fixed wireless provider, and now I'm into fiber. So I'm a CTO for a fiber. And I'm evaluating SD-WAN as well as some of the other products here to roll out, just like you guys. So SD-WAN, software-defined networking, wide area network, really has two perspectives that people come at it from. There's the carrier perspective, and that's really about, it's kind of an implementation of SDN out on the wide area network, and that's not what we're talking about here, okay? So, if you're thinking of SDN making WAN connections for you between carriers, that's a different play on this. So as you go out on the internet and try to look this up, you might see some of that going on out there. What we're really talking about is SD-WAN from a customer perspective. Managing, from a customer perspective, managing your WAN connections. So let's see here, next slide. So really, when you want to manage your WAN connections, you want to manage them these three ways. And what SD-WAN does is it allows you to manage them from the cloud. And usually you're talking about multiple sites as well. So it's kind of replacing VPN technologies. It's replacing MPLS technologies. And it's managing each each part of your WAN bandwidth management. Excuse me, can you hand me my water down there? Thanks. Bandwidth management by application. So how much of the pipe is this application going to be able to use? And it also allows you to prioritize packets by the application, who's first in the pipe, who's last in the pipe. WAN circuit utilization, which circuit to use. If you've got two or more, what do you use by application? Some applications, require higher latency, or not require, can handle higher latencies than others, and some require higher bandwidth than others, like disaster recovery requires really high bandwidth and requires it at night typically, but it doesn't necessarily have to have a low latency circuit. Also failover by applications. Prioritizing if one circuit fails, what applications then get to use the pipe at that point. So all of this has been done by other types of devices in the past, such as firewalls or UTMs, but combining them all into one, making it easy to use, and then putting the control in the cloud is really what SD-WAN is all about. So I'm going to pause a second. Anybody have any questions about SD-WAN at this point? Okay. So the primary advantage of SD-WAN is that it is a cost savings. Now it's going to not make sense here when you see the next slide, but if I've got 10 sites, I'm a bank, I've got 10 sites, and I'm going to put fiber in 2 of them, and the other 3 are in small rural areas, or the other 7 are in small rural areas, and there's no fiber available there, then I'm going to start looking for broadband technologies. So what do? I can put in a couple different types. I can put in DSL, I can put in cable, I can put in fixed wireless, because I'm trying to have a very capable, reliable transport circuit back to my own data center. So instead of making the build for fiber all the way out to that location, I can put in 2 broadband circuits. So I'm saving cost as an IT guy by using SD-WAN. So basically, it's the advantage is where fiber is not available, I can do some other type of circuit. Does that make sense? So your disadvantage, though, is, and I'm telling you the disadvantages, it depends on the SD-WAN provider, whether this is a disadvantage or not, but you essentially have a single point of failure now for that branch. Even though you've implemented 2 WAN connections at that branch, you now have a box in front of both of those connections that could fail. So the other disadvantage is this is a Band-Aid. It's a Band-Aid for good high bandwidth or good reliable bandwidth. It's not a final solution. So is it disruptive? I've been to recently to like I said, I'm a CTO for a fiber company, and the fiber industry as a whole is trying to evaluate, is this technology friend or foe to them? Meaning, is it a competitor to them? And I believe it is. Even as the provider, I believe what it's going to do is it's going to make all the other solutions still capable of doing the job. So if you take a look at this little chart here, if you have SD-WAN managing your wide area network, then you can pick any one of the other types of solutions to include fiber, and you can accomplish everything you need out of it by adding them together. So you can even, such as mobile wireless, it's got a medium download, a small upload. It's not low latent. It is not low jitter. You can have redundancy with it, and its cost is high. So you can add, if a bank wants some redundancy, a branch bank wants some redundancy, they can throw mobile wireless in, but if they're not managing it, they can blow through some expensive data in a short amount of time. So if you use SD-WAN on top of any other connection, then basically you've got the best out of all of it. Does that make sense? Everybody follow me here? So now the reason why I'm telling you this is because having been in internet service for quite a while, What I do know is whoever's billing the customer owns the customer. Whoever is that trusted source for the customer, whoever's already in there, they're going to own that customer for the longest time. Now, what do we know about broadband solutions? Once you get into, especially a business, I'm primarily talking about businesses, although it's true for residential. Once you get in there, does the customer just love to change ISPs? Anybody who has a customer that changes ISPs every 3 months because they just love that transition? They don't, right? It's a painful process, especially in businesses. So this would make transitioning between ISPs a lot easier because it makes it a commodity. Your SD-WAN box sits in front of all of your providers, and then you just basically plug in a different provider and then transition between them instead of having to cut over your transitioning. So my point in all this is if, by the way, I'll give you a little hint here. Many of the carriers have purchased SD-WAN companies so they can have that front end for the customer, and they can provide this as a service as well. So as an ISP, can you do this? You betcha. You can do it for small businesses. You can be the SD-WAN provider and provide one of the circuits that is connected to it. As well, if you really wanted to, you could come in and provide the second service through DSL or something like that. So this is primarily, SD-WAN capabilities are primarily focused on businesses. Is that any questions at this point? Nope. Okay. So where does this really fit? Private networks, MPLS type networks. So in your markets, you probably have, large corporation branches, medium-sized banks. They're all implementing some type of MPLS or fiber-based private network. And they always have a few branches that are hard to get to. And you as a provider could be one of those solutions for that branch using this technology if you present it as part of it. It's also potentially an alternative to a BGP for some providers or for some customers. So if they're looking for, BGP provides a both incoming and outgoing alternate circuits. So if I'm hosting something, then I use BGP to announce to the rest of the world on both circuits what I'm hosting. That's a quick one there, so if anybody wants to correct me on it, feel free. But basically, this could also do the same thing for you in the future, meaning in the future, this technology could eliminate your need for BGP on a circuit. So finally, the last thing I wanted to bring up is, this is kind of already baked in. Excuse me, it's kind of already baked in with certain firewalls, and eventually will be baked into CPE that you purchase from your carriers. What I mean by baked in is, for instance, I'm a big FortiGate guy. I love FortiGate. Any other FortiGate providers in here? It's a firewall. It's a UTM, a Unified Threat Management Device, so it handles a lot more than just firewall. But now they're adding SD-WAN. They've kind of already had it in there, but now they're calling it SD-WAN and adding services to it in their latest firmware upgrades. So SD-WAN is already coming to the market in a lot of places you may not even realize. My suggestion to you is evaluate whether this technology would be a good add for you as a service provider. And then there's about 8 to 10 companies out there doing it, and they all have different takes, different pushes on the market. So evaluate it and then ultimately make a choice and then run with it or not, knowing this information.
So those are 3 definitely very interesting technologies. I hope you guys were writing down questions. So I'd like to open up for Q&A. We got about 20 minutes or so. Does anybody get any questions to start off with? There's a microphone right here. If you could come up and ask the question in this microphone here, it'd be great. Actually, it might be easier. I'll let you, yeah, go ahead and ask it around.
I had a question on the SD-WAN. Is there a need for standards, or are there standards that will be developed for the SD-WAN if manufacturers are going to be developing that into the hardware? Is there any need for standards?
It's a good question. You know, if you're talking about SD-WAN on the carrier perspective, there kind of already is. It is called MEF, Metro Ethernet Forum CE 2.0, C 3.0, but that's really from the carrier perspective. From the customer perspective, I have not heard of any. I'm unaware of it. You know, and that's probably the best answer I could have for you. It's really more about taking current network flows and being able to visualize them and manage them both from a strategic perspective, but also on an active basis, if you understand. Meaning you're taking a multi-site network, looking at all of your different traffic flows and saying, in general, my VoIP traffic has #1 priority, and it gets both utilization of both circuits. You know, secondary would be disaster recovery or something to that effect. And then as well, you know, something you really can't do well currently with any technology other than SD-WAN is you get to visualize it happening. I don't know if anybody's familiar with Allot. There was a company named Allot. There still is a company named Allot, and they had a really good bandwidth management box. The good thing I loved about it was you could visualize every IP flow that was going on through your network at that time, and then you could prioritize it and do that kind of stuff. That's what this does for the customer instead of for the service provider. Did I answer your question? Okay.
Any other questions?
Who was that vendor that did the threat management that had all this bundled in?
FortiGate. Well, Fortinet, sorry, you're right. Fortinet is the vendor. FortiGate is the product.
Any other questions? You guys are going to make me ask all the questions, right? Because I'd hate to do that.
So it sounds like the SD-WAN is really just a quick and easy front end to setting up a bunch of IPsec tunnels between like the public internet and like and various endpoints. Is it generally a layer 2 connection or a layer 3? I know with IPsec, it's difficult to run OSPF across that unless you like throw GRE tunnels in there as well. What does the customer wind up seeing as the pipe? Is it, like I said, is it a layer 2 connection usually in these?
It depends on, like I said, there's multiple providers of this capability. Almost all of them are some type of layer 3 implementation. It's not a layer 2 generally implementation because you're bringing on layer 3 circuits to perform it. In other words, though, you're probably asking, do you see it as a layer 2 connection? You know, I haven't seen that in an implementation yet. So it's not going to replace, you know, doing a virtual LAN, but VXLAN or any of those protocols, if that's what you're talking about.
In regards to the millimeter wavelength with the point to multipoint, the configuration that you showed was a 90-degree sector array. If you intend to have higher density than the, I think it was eight units per base station within a 90-degree sector, at least specifically for that type of product, how do you anticipate being able to fulfill more density than that within whatever sector degree you have configured?
Sure. So, you know, the easiest way, and it's not really addressing your question, is you put 4 base stations up there, you get 360 coverage, you've got 32 subscribers. One of the things that we're seeing is that this is really much more of a capacity limited type of deployment. You run out of gigabits before you run out of anything else. So when you're only going, you know, 1,000 feet, you know, 32 people within 1,000 feet of your base station getting a gigabit per second each, that's generally okay. We're all the vendors, ourselves included, are looking to increase that to 16 or 20, but I don't see it going much beyond that because you're going to run out of capacity when what the market's demanding today is a gig. Does that answer?
Yeah.
Okay.
And regarding the millimeter wave, I know they're really short distance and whatnot, but what if you had say you had two vendors going on at the same time in a real close area, how well are they going to play with each other?
So, you know, I'm glad you asked that question. It's something I didn't really emphasize too much, but one of the real benefits about the millimeter wave is the lack of interference, and there's 2 reasons for this. One, there's a tremendous amount of spectrum. The FCC just expanded this band from 57 gigahertz to 71 gigahertz. So you're talking 14 gigahertz of spectrum to put your equipment in. For us, and I think most of the vendors that are doing the point-to-multipoint, it's a 2 gigahertz channel, so you've got 7 channels that you can use. The other element is that because you're at this high frequency, the Fresnel zone, the radio beams themselves are very, very tight. So you have spatial discrimination. You could put 4 base stations of our product on the same frequency channel, on the same tower, and there would be no interference. And when you couple that with the third element, which is it's really only going 1,000 feet, as I mentioned, right? We're not going long range. You really, between the abundant spectrum, the narrow beam, and the shorter range, you don't really going to run into any kind of frequency congestion issues. Very, very different from the 5 gigahertz band today.
Yeah, I think I could also add to that, David, that the other nice thing about 60 gig is that the resonant frequency of oxygen is somewhere around 62 gigahertz off the top of my head. Yep. So it's not even, the reason why it's very distance limited as well is that after about a mile or so, the signal has almost completely been absorbed by oxygen. So right at the peak, I forgot what the exact point of the peak is, but it's, I do remember it's 14 dB a kilometer of attenuation just from air. So it's unlike any other frequency band that we use. Like for instance, the only reason I remember these numbers a long time ago is with Bridgewave. I work for Bridgewave, another millimeter wave company that's here in the exhibit hall. And 80 gigahertz, for instance, is 0.3 dB a kilometer. The 5 gigahertz is like 1/100th of a dB a kilometer for atmospheric attenuation. So it adds a very unique aspect to it that you can put a lot of these devices very close together, and you don't have to do frequency coordination because quite literally there's no signal left after a mile. It's just gone. So it's a really nice thing about the band as well.
I told you I was evaluating millimeter wave as well, and I have a question for him. And this is a strange question. I was at another conference, and the CTO for T-Mobile was there. And he said that he's implementing 20,000 small cells, and the small cells are going to have both a 600 megahertz side and a millimeter wave side, and the expectation on the millimeter wave side was that it was going to reach out 1,000 feet. So my question is do you agree with that 1,000-foot range, or is it better? His 600 megahertz, by the way, was going to go out 6 miles. So his expectation was he's going to be able to, with 20,000 small cells, he's going to be able to reach a lot of market. So you shook your head yes.
Okay. So 2 things. Like any technology or any market buzz that goes along, there's a lot of hype. You're going to hear people talk about millimeter wave, what we classically call microwave, 28 gigahertz, 38 gigahertz. A lot of the U.S. carriers, when they talk about millimeter wave, that's the frequency they're referring to, and that's a very different propagation, very different, that frequency is very different from the 60 gig, 70 gig. In terms of the 1,000 feet, that is about what you should be expecting from a point-to-multipoint, at least from a Siklu system. Again, we have proprietary patented antenna designs that get us that 1,000 feet that make it difficult for others to do it. But if he's a T-Mobile guy, my guess is he was thinking LMDS and 38 gigahertz.
David, correct me if I'm wrong. I think millimeter wave starts at 20 gigahertz, technically?
No, I think it actually starts at 42, I think, is the physicist's definition of a millimeter wave. So
Yeah,
it's, like I said, I've seen 700 megahertz systems be called millimeter wave lately, so who knows?
Oh, sorry. I missed you.
You mentioned soft licensing for those millimeter, easy licensing. Just how, because that's something that's just daunting. Anytime you have to, honestly, just go to FCC ever, it's kind of a daunting task. So in regards to that, is just a brief, maybe, what is the process to go through for licensing or anything for the millimeter wavelength?
No, I understood the word licensing has some very traumatic connotations for many of us in the room. And as you said, you'd rather not talk to the FCC if you don't have to. But this is actually where they've gotten it right. When they call it light licensing, you go on the website, you put in a little bit of information about where your link is going to be, coordinates, et cetera, what's the manufacturer, vendor, and then you're going to pay a couple $100 fee, and that's it. I mean, it is really, you're not going to have to there's no multiple pages of documentation and filing, and you don't need a consultant to do this. And in fact, we have a little tutorial that'll take you, how to do this. It's pretty easy. It's nothing to be afraid of.
Sean, I'll ask you a question. How is, for Gfast deployment, how is that deployed in an MDU differently than, say, a DSLAM for DSL? What's the primary differences in the actual installation?
Okay. Actually, there's a lot of similarities. So if you've actually deployed a VDSL DSLAM in an MDU, the setup's similar. The equipment looks similar. You're going to be 1U to 2U rack unit. And you're going to be connecting it to existing infrastructure. The real difference comes is in the frequency spectrum that you're going to be utilizing, either 106 up to 212 megahertz that you have to consider. So in that sense, if you've deployed VDSL DSLAMs, its installation is very similar, with the exception you just have to really consider the higher frequencies that you're utilizing. There are some instances where we've seen interference from, say, in-building, especially in older buildings, intercom systems and so forth that may also be on adjacent pairs. But really, there's not that much difference. The key thing is you're going to be getting, a significant 3 to 4x of the total bandwidth throughput that you would with VDSL, and the same advantages of utilizing existing infrastructure. One difference may be in terms of the type of uplinks. Typical DPUs, which is equivalent to a DSLAM, are going to give you an option to have SFPs, so you can put in your particular uplink of choice, whether it's gigabit Ethernet or it's a fiber-based alternative for the uplink. So I would say there's more similarities than there are differences, but 3 to 4x your bandwidth easily.
Well, let me ask you another question then. I'm sure I'm similar to a lot of the operators in the room that when I was a WISP, when I was an installer, I never actually installed VDSL. So how complicated is it to install?
Well, some of the differences may be, and actually I was just out on an install in downtown Oakland about a month and a half ago with a local WISP. And actually one of the pictures I showed of that rat's nest was the actual installation panel where we were hooking things up. And what I learned is the WISP tech simply carried a Fox and Hound tone set. They just toned out the lines from the customer unit all the way down to the patch panel. That's fine for traditional DSL services where you're maybe talking about 25 to 100 megabits maximum. With Gfast, you need to get a little bit better sense of that line quality. And what we're recommending is taking that next step and start looking at what is the impedance on the line, some of the more detailed characteristics, which you can actually, through tools that Scipio makes available to our vendors, you can actually run a lot of diagnostics on that line just by connecting up the systems and find out where you may have some spectral interference from adjacent technologies and so forth. So the recommendation is that you have to go beyond just toning out a line and really understand what's that copper look like, especially in a lot of these older buildings. So then you'll get a better idea what I can offer my customer, and maybe some minor grooming things that will take place in terms of how you place your lines, how you punch them down, and so forth. Higher the frequency, you get a bit more sensitive in terms of your crimps, at the customer side, and your punch downs within the closet as well become very important.
So basically just like a DSLAM at the customer's side, it's just a set-top box, right? Nothing different?
Yeah, it's at the customer side, it's going to be the same thing. It's going to be a couple different scenarios. It's going to be a integrated router, a gateway with a Gfast interface, which you can purchase today, or it's going to be a gateway with an SFP. So there's gateways now and there's Gfast SFPs, so you can just insert an SFP at the client side, or it's going to be a dedicated, just a basic Gfast modem bridge with a gigabit Ethernet port out.
A question for the whole panel. what is the quickest way to get the best ROI on each one of your individual technologies? Where is it going to shine the quickest to get your money back? And just ask each one of you if you could provide some quick.
I'll attempt this because, again, the advantage of utilizing, whether it's, again, a DSL or Gfast, is that your ROI is going to come in not having to rewire the building, right? There's a lot of money. We've done some analysis, anywhere from $300 to $600 per unit, depending on where you are, to rewire from the closet to each individual unit. So you're going to be savings off the bat by utilizing something like Gfast to not have to do that rewiring piece. One of the things that we've done and Scipio's been doing within the industry, and the more we learn about the requirements for the WISPs, is looking at what are the bare bones requirements that you need in a piece of equipment versus, say, carrier class requirements that an AT&T or somebody else would utilize. So you're going to start seeing coming on the market some boxes and solutions that make it a lot easier in terms of your financial decisions and your return on investment, because it doesn't have a lot of the higher end requirements. It's really more bare bones things, so you can very quickly integrate it into your network. You can get a connection up and go in and start passing data.
Well, the fastest way for ROI is to charge people a lot of money. You just won't have a lot of customers. But for fixed wireless, the market's really always been kind of segmented into the enterprise and the residential. Fastest ROI is going to be for the enterprise, who are willing to pay for symmetric bandwidth. They generally have higher needs. But the larger market is clearly the residential. For us, when we're building equipment, we're doing our R&D, we're looking at the business case, we're looking at an ROI. And our ROI, our goal for you guys is what we think this market needs is 12 to 18 months. Equipment's going to roll over every 3 to 5 years. That's just kind of the way it is. There's new technology. There's going to be, 5 years from now, you'll be offering 10 gigabit per house. I don't know. I can't even keep up anymore. But the idea is, when we're looking at your costs, we're trying to see if we can get you an ROI in 18 months maximum.
SD-WAN is really more about keeping the customer long term. So if you want to extend out your ROI, you have to add services generally. And so it's actually an additional cost it's not going to save you in the short term. It's going to customer save you in the long term. Does that make sense?
Yeah, reduce churn effectively, right?
On the Gfast, are there any plans for extending that range of the 300 meters? So in a real case scenario, going into a small market that already has a cable network built out, and being able to go in and partner with that cable company, provide the technology to get internet over that coax, but to go out further, to houses as opposed to just in a building structure.
So Gfast is really designed as a short-range technology. It's really limited by the frequency range that we're utilizing. But with that said, if you're working over a coax environment, that 300 meters is going to become 600 meters or more, depending on the type of coax that you're using, and it becomes a much longer over twisted pair. The sub 300 meters, 150 meters is really over existing twisted pair environment. But with that said, there's two ways to get longer distance. Really, one way, and that is by means of using bonding, where you may have a very poor infrastructure that is limiting your distance, but you're trying to target, say, a specific rate, 500 megabits, and that's where you can bond two pairs together, or even more than two pairs, to get your required bandwidth over a specific distance.
Yeah, this is about SD-WAN, and I'm just wondering if anybody's implemented it using Microtech routers, or if you're even familiar with Microtech.
I'm familiar with Microtech, but I haven't done anything with the SD-WAN stuff.
With the Gfast, in an apartment complex scenario, I've been in hundreds of them. Most of the twisted pair is 6-pair with no sleeve on it. So, and it's all chained at every jack in the apartment. So, have you run into that scenario where your application is going to help?
Well, again, Gfast is going to be very similar to deploying a VDSL technology, where it's point to point. So what you're going to have to do when you go from the wiring closet into the individual unit, you're going to choose one of those pairs that terminates at a specific jack. DSLs and Gfast are very susceptible to what we call bridge taps, which in that scenario you would have additional connections hanging off of the primary connection. So our recommendation is to terminate it at one jack with one single pair and not let the additional daisy chains go around be hanging off the same pair.
So you would take the jack plates off and cut the cables?
If that's the case, what we're seeing in most installations today, where Gfast is coming in and replacing an existing DSL. So it may be some old ADSL technology in place in VDSL, and in that case, all the pre-wiring is already done, and they're even being done in self-installations. The modem's left at customer doorstep or shipped to the customer. But if it's a new install, the recommendation would be that you would need somebody to go into the home and make sure that jack is set up appropriately.
Well, I hate to say it, but we're bumping up right against the end of the session. So I want to thank our speakers for speaking this morning, and I'd like to thank everybody for attending. Certainly, if you got more questions, I encourage you to come up and ask speakers individually. Thank you so much for attending. Have a great show.